Welcome to the only YouTube series where we will discuss Android concepts in under 15 minutes. On today's menu, data persistence and data storage. So let's bring up a 15-minute timer and start this video. Data persistence in its simplest form is making sure that when we close our app and reopen our app, the data we need to be saved is actually saved and reopened. We can imagine that when we have a certain state, a user has done something, and they exit the app, they want to make sure that when they re-enter the app, that data is still there. Now for this we have to be aware that apps can be destroyed. If you don't remember what that is, please feel free to check out the video on Android lifecycle that is linked either somewhere here, or maybe here, I don't know. To achieve data persistence, we have 4 ways. There's app-specific storage, there's shared storage, there is preferences, and there is databases that we can use. In today's video, we'll mainly go into the last two, databases and preferences. But let's start with what those first two are so that we know what it is. Whenever an application is installed onto a phone, Android gives it its own sandbox. This means that this application has its own location for storing data and no other application can access that location. The data we can store in there range from structured data, like JSON files, to unstructured data, to plain text files. We can even serialize classes and store media files as well. Now we can access this storage using the functions getFilesDir or getCacheDir. And we don't need any specific permissions. Now of course this doesn't work if we want to share the data that we save with some other application. For this we need to use the shared storage. This storage is shared between multiple applications, and any application that has the right permissions can access this storage. We can save media files here, and we can save documents here. For documents it is pretty straightforward. We can use the storage access framework and we don't need any specific permissions. For media files this is slightly different. First of all, we need the read external storage permission in our manifest, independent of what API we are programming for. Now, if we're programming for phones with an API under 29, we also need write external storage permission to be able to write to the shared storage. If you have a newer phone with a higher API, you don't need this permission. To store the media files, we need the Media Store API. Now, this was a very short overview of what is app-specific storage and what is shared storage. Now let's look into databases and preferences. We'll start with talking about preferences. Preferences offer a lightweight way of storing key value pairs. This means that a key is some sort of name that we use to reference where we stored something, and the value is just a singular value that we store. For example, we could store the username and then store a string containing the actual username. You can think of these preferences like your quick notes on the phone, and you can use these preferences mainly using 2 frameworks. Either shared preferences or data store and then specifically preferences. Now of these two, shared preferences actually is the most old API and works fairly well. It has a lot of examples online and I would just highly recommend using it. However, data store preferences is slightly newer and it brings some new benefits to the table. Namely, one of the issues in shared preferences was that it isn't asynchronized and we couldn't really listen to it, meaning that we need to actively ask the system if there is a new value. In data store this has been handled and it's been made asynchronously. We can listen to the value by getting it as a flow. If you've watched the video on state flow, you know that once we collect a flow, we keep getting updates on the value when it changes. So this means we only have to collect the flow once, and then whenever the value gets updated in the storage, we also get this new value to our view or wherever we need it. Furthermore, data store has the ability to actually throw exceptions, meaning that instead of just getting an error and we don't know what it is, we can actually handle I/O exceptions, or we can handle other exceptions we might get. To implement the data store, we first create a data class that describes the structure of the data we want to save, so that the data class can contain multiple values, which will be the key value pairs we want to save. Then secondly, we have to create a class for the data store itself. This class will handle the interaction between the app and the storage side, and uses the data class we just made to define the structure of whatever will be saved. Be aware that this class needs context, so we need to put it in a location in the app where we can actually pass the context to it. Now, whenever we made it, we also need to make sure that it ends up at the right locations in our application. To do this, I highly recommend using dependency injection, either using a library like Daggerhilt, for which I will link a video down below in the description, or you can use manual dependency injection, but then you have to be a little bit more careful. Now that we've seen how we can use and implement preferences, let's move on to databases. A database is a collection of structured data. It can easily be accessed, or stored, or searched, or organized. Android by default comes equipped with an SQLite relational database. In SQL, data is stored in tables, so it has columns and rows, and the columns define which kind of values we will have. For example, if we take the car table, it might have a column for the make of the car, the model, the year it was made, and some sort of ID specifying the actual car. Now each row in that case will define a new car. The ID column in a table is often a little bit special because it has to be unique. We also call it often the primary key, which we use to reference to each row. Now using the SQL language allows us to create these tables, create new rows, update rows or delete rows. These operations are often summarized by the acronym CRUD, standing for create, read, update and delete. We can interact directly with the SQL database using SQL language. However, this comes with the downside that we don't have compile checks, meaning that we only get errors once we run our app, and there's a lot of boilerplate code to transform the data we get from the SQL table into data classes that we can use in our app. To fix these issues, the Android Jetpack developers have created the Room Persistance library. I would say that this library is actually more of a layer between our app and our SQL database and allows us to interact between these two. To implement Room, we have three major classes we have to write. We need the database itself, of course. We need the data access object, often abbreviated by DAO, and we need the data class defining the structure of the row. And we call this the entity. Now let's start with this entity. One thing you should know is that when using Room, we need a lot of annotations. And for this we need dependencies. You can add these in your Gradle file, but I'll link the dependencies that you need below in the description. Now if you've implemented these dependencies, you can use the @entity annotation for your data class. And there we can also specify the table name that it will get. Now within this data class we define which values we need in our row. So which columns we're going to have. Of course the first column is going to be your ID column, your unique identifier of that row. And in Room we can annotate this specific value with the @primary key. And this allows us to also tell Android whether or not this key will be auto-generated or if it needs some other settings. The other columns we can usually just put the value there. However, if we want, for example, to change the column name to make sure that it's not the same way the value is in the data class, we can use the @columninfo annotation to change that. Now, if we have defined this, our entity is done and we can move on to our DAO. The DAO contains all the methods for interacting with our SQL database. We create a DAO by creating an interface. And if you remember, an interface class is always some sort of blueprint. So it is the blueprint of all the actions we will have. Now we annotate this blueprint or this interface with the @DAO annotation to make sure that Android knows that it's part of the Room database. Now within this interface, we can define all the functions that we need to interact with our database. Remember the CRUD acronym. Room basically has very similar annotations, so let's go through them. The first annotation we can use is the @insert annotation, and then we can define our function beneath. We can use this annotation for inserting a new row into our table, and we do this by passing an entity to the function. The second annotation we can use is the @update annotation. When we pass an entity to a function that has been annotated with @update, it checks if this entity exists in the table, and when it does, it updates the values according to the new entity that we've passed. we can use the @delete annotation to delete rows. Now here we once again pass an entity, but instead of updating it or creating it new, it will look for this entity in the table and then delete it when it's found. You might wonder what happened to the R of our CRUD acronym. Well, the R is slightly special using these annotations, because it uses the @query annotation, and then it allows us to do a specific piece of SQL code in the brackets. Now this is particularly handy because often when we read, we either want all the values, but we might also want to filter the values so that we only get a specific subset. Now using the @query, we can define what we want and we just have custom control over what gets received. Now with all these operations, we're able to get back flows, meaning that we can collect them and we can automatically update wherever we need or collect these flows. Now that we have all of our operations defined, we can move on to creating our last class, namely the actual database class. To create the database class, we create an abstract class and we annotate it with @database. Now within this annotation, we also define which entities this database will have, meaning which tables. We create a version number and we tell it if there will be an export schema or not. Now this export schema is mainly for when you have an old database and you have added some column values, how you will export the data from that database to the new one. For now, that will probably not happen so often in your apps, so you can set it to false. Within the database class, we have to define which DAO that we're using. And we can do this by creating an abstract function within the class and defining our DAO there. Finally, all that is left is to make sure that we can access this database throughout our application. For this, we first have to build it somewhere that is accessible. Some people like to create it in the application, in the onCreate. Some people like to create it in the main activity. However, you can also create it in some sort of dependency injection library, such as Dagger Hilt. Now, once you have done this, you can pass your database to wherever in the app you need it, and thus interact with it through the DAO. Now, this was pretty shortly all you need to know about data storage and creating data persistence. So the key to having data persistence is making sure you store your data in the right way and collect your data again when you reopen the app. The next step in your journey is to start implementing these methods into your own applications. Create a shared storage, create a room database, create some preferences that you will save. And by this you will learn a lot. Now there's a lot of examples online, so I won't bother you with that. But if you like this video, feel free to subscribe down below, and I will see you in the next video.